In the previous lesson, we talked about dilations of trig functions, and now we're going to add translations. So in the last lesson, we looked at this as it's a dilation. It affected the period, and we have a formula for the period, which is 2 pi divided by whatever this number is, 2 pi over 3. Here, we don't divide by 3. This is actually a 1/3, so we'd go 2 pi divided by 1/3, and that would give us 6 pi. Frequency is also just the reciprocal of period. So here we do the reciprocal. So what we talked about in the previous lesson, we would have, this is a vertical dilation, here's a horizontal dilation, and today we're going to add in the horizontal shift. It's also called a phase shift in trigonometry, and the vertical shift. We have to be careful not to just take whatever's written here, because this has to just be x. So this is not the phase shift or horizontal shift. We have to factor out a 1/2. In this problem, we'd factor out a 1/2. And now this is the phase shift, and it's going to go left 2 pi over 3. So let's graph this. And this is not the horizontal shift. We have to factor. And we just have to look at, have something here. If you can't figure out what goes there, just you can take a guess and then multiply by half and see if you get 2 pi, pi over 4. And here's 2 pi over 4. If we multiply by a half, it would cancel the 2, and then we'd be left with pi over 4. So now we see that here is the horizontal dilation, and there's the horizontal shift. We could reduce that to pi over 2. And well, let's look at some of the characteristics. We have amplitude is 1. Period is 2 pi over a half, and that gives us 4 pi. And that means the frequency is 1 over 4 pi. And we also have phase shift. And that is negative pi over 2. Here is a inside change. Pi over 2 is inside. That means it's horizontal, and we do the inverse of this. So we're going to go, the phase shift is negative pi over 2, and the vertical shift is 0 because there's nothing out there. All right. Now we'll do, let's use the points of the parent function, cosine x, and we have 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi 1. Okay. Then we have a horizontal dilation, and we're going to make sure we do this first, and then we'll do that. These are both horizontal, so they're going to change the x value. Here we have 1/2 times something, so that means we're going to do the inverse of that, and we'll divide all the x values by a half. Dividing by a half is multiplying by 2, so let's multiply the x values by 2. Multiply the x value by 2, multiplied times 2, multiplied times 2, times 2, okay, and then we have cosine, and it'll be x plus pi over 2 and now we have to subtract pi over 2 from all the new x values, so we'll go minus pi over 2, pi minus pi over 2, 2 pi minus pi over 2, 3 pi minus pi over 2. This will be 6 over 2, so I'll get 5 over 2. And this will be 8 over 2 minus 1 is 7 pi over 2. And then we can just graph this last set of points. Seven pi over 2, and we need to have, for the transformation, we need to have these points, and they are going to be pi over 2, I'm going to have to start over, and 7 pi over 2, and we need to have this be negative pi over 2, because that's where one cycle starts at negative pi over 2. So here, this will be 1, 2, 3, 4. Negative pi over 2, here's pi over 2, 3 pi over 2, start again, negative pi over 2, and we'll have to then say that that's going to be pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 7 pi over 2. Here's going to be 3 pi right here. Alright, and we can plot this point, negative pi over 2, 1, pi over 2, 0, 3 pi over 2, negative 1, 5 pi over 2, 0. 7 pi over 2, 1. And we could compare that to the parent function, which starts at 0 and goes to these points. Okay. And pause the video and try that one. We have to think of what would go here so that when we distribute the 3, we have pi over 2. And if we just put a 3 in the denominator, because I'm going to multiply by 3, we need to cancel a 3, so that would make sure we would have to have a 6 in the denominator. And let's list the amplitude is 1. The period is 2 pi over 3. The frequency is 3 over 2 pi. Phase shift is pi over 6 moving to the right, and the vertical shift is 0. So then we do parent function, and we have 0, 0, pi over 2, pi, 3 pi over 2, and we should divide the x values by 3 and then add pi over 6 to the x values. Divide by 3, divide by 3, divide by 3, divide by 3, and then we have to do 3. We're going to add pi over 6. We have to add pi over 6 to the x values. So we're going to add pi over 6, add pi over 6. We get 2 pi over 6, or pi over 3. We're going to add pi over 6 here, and that'll give us, this is 2 pi over 6 plus pi over 6 is 3 pi over 6. That would be a pi over 2 plus pi over 6 here. This is 3 pi over 6 plus 1 pi over 6, 4 pi over 6. And 4 pi over 6 plus 1 pi over 6 is 5 pi over 6. So if this is pi over 6, that's where it will start. And then this is 2 pi over 6. We just have to go pi over 6, 2 pi over 6, 3, 4, 5. and this will be pi over 3, pi over 2, 2 pi over 3, 5 pi over 6. So there's the transformation, and we could look at where the parent function would be. Here's pi over 2, so then this will be pi, and we go twice that distance, that'll be 2 pi. So we can see that this is where those parent function points are. Alright, so now we have more transformations, and we'll make sure that we do the multiplication and division first. The amplitude is a half. Vertical shift is down 3. We don't see the horizontal shift yet. We have to factor out a 1/4. And if we need to cancel, we multiply by 1/4. We need to have a 4 in the numerator, so that when we distribute that, it'll cancel and we'll get back to where we started. Alright, so we have to divide the x values by 1/4 and multiply the y values by a half. And we can just do both dilations at the same time, so that'll be 1/2 sine 1/4 x. We're going to divide the x values by 1/4 or multiply by 4 times 4 times 4, 4 pi over 2 times 4 times 4 here, and we'll get a 12 over 2 is 6. We also see 2, 4, 6, 8. Then we have to multiply the y values by a half times a half. Alright, and then we will add 2 pi to the x values and subtract 3 from the y values. This is 2 pi. So let's add 2 pi to the x values. And subtract 3 from the y values. So this will give us negative 2.5 minus 3 minus 3 minus 3. All right, and we're going down further. We have a minimum of negative 3.5. And starting at 2 pi and going out to 10 pi. We start at 2 pi, negative 3, 2 pi, negative 3. At 4 pi, we go to negative 2.5. Back down to negative 3, negative 3.5, and negative 3. And this line just helps you keep it even. We would go to here and then back up. And how has that changed from the original? The original was within from 0 to 2 pi, so that was like this. So that one changed a lot. Alright, and pause the video and try this one. Amplitude is 2. The vertical shift is 1, and there's no phase shift, and this 1 would have to be in parentheses for it to be a phase shift or horizontal shift. It's not inside with the x, so that's a vertical shift. We don't have any horizontal change in this problem. We're going to multiply the y by 2 and then add 1 to the y. Multiply the y value by 2. And then we're going to add 1 to the y value. So we're going to be at 0, 3, 0, pi over 2, pi. We didn't have any changes in the x, so that'll be the parent function x values. We have 0, 3, pi over 2, 1, pi, negative 1, 3 pi over 2, 1, 2 pi goes up to 3, and we can just check if there's the center. We'll be going up 2 from the center and down 2. So there's up 2, down 2. We also see the vertical shift is how far this moved. I'll stop there for today.